All right, so the last thing that we're going to talk about is how the relationship between two variables. All right, so there's three ways we can talk about the correlation or the relationship between two variables. So we have two numbers and how they relate. They can either relate positively, negatively, or basically are uncorrelated. And so what we mean by positive correlation means if one of them increases, and the increasing one is the independent variable. It's typically time, but not always time. So if one of the variables increases, it causes an increase in the other. All right, and we call that positive correlation. That's when we're moving up, increasing. Similarly, when we have two number values, we call them negatively correlated. If as one increases, and again, typically that's time, as time goes on, then the value of the other value comes down. It decreases. So as one increases, the other decreases, and that would be the decreasing case. So we'd have the negative correlation. If it looks like that neither one of them are related, all right, there's no correlation at all, we just say they're uncorrelated, or have very little relationship between. One number really doesn't affect the other in any pattern or way, so there's no correlation between the two numbers. All right, so the first is just a couple of examples just to see if you can kind of tell if something is positively or negatively related as an application type. All right, so the first example is, suppose that we are trying to correlate the number of beers consumed on a Friday night, and the BAC would be the blood alcohol content level of the person consuming the beer. So as you consume more beers, all right, that would be the increasing of one variable, how is the blood alcohol content behaving? Well, it also increases, right? The more alcohol you put in your body, the higher your blood alcohol content. And so as one increases, so does the other. And so that would be the positive correlation. And it is correlated, right? One affects the other. The number of alcoholic drinks you drink affects your blood alcohol level. All right, the second example, the temperature of coffee and the length of time it sits out. So suppose you pour yourself a cup of coffee and you leave it on the counter. Right? Usually when a coffee comes out of a coffee pot, it's somewhere around 104 degrees, somewhere around 100 degrees Celsius. Or sorry, degrees Fahrenheit. And then if you leave it on the counter, what happens is the temperature decreases until it reaches the room temperature. So room temperature is somewhere around 70 for most places. And so what's happening is then as the longer the coffee sits out, so as time increases, the temperature of your coffee decreases. And so that would be and it is correlated, right? There's a relationship between how long your coffee sits out and how hot a coffee it is, right? Oftentimes we've left the beverage out and it will get, especially if it's a hot cup of coffee, it would be negative. Now if it was, suppose, iced coffee, it would work in the other direction. It would be a positive correlation. It gets warmer as you have it sit out. But we're going to assume that it's a cup of coffee that's hot. So I'm going to do a negative because I want one negative and one positive. All right, so that's an example of the correlation, descriptive correlations. The next example is talking about scatter plots and linear correlation. So basically, if I can draw a line between my points, if the line is increasing, it's a positive correlation. If the line is decreasing, it's a negative correlation. If I've got a line and the points aren't even near it, we would consider it little to no correlation. All right, so my three graphs here is one of each case. All right, so linear correlation, I take my lines, and so I'm going to pick a different color than blue. And so I've got this first scatter graph here. And so if I draw a line, sort of the best fit, what we call the best fit line, and that's what you usually find in statistics, you'll find the best fit line of points. And if I draw my line sort of in the middle of all my points, my line is moving in an upward direction in that case. And so we call that a positive linear correlation. All right, there is a linear relationship, and it's positive. It's moving in the as my x values get bigger, so do my function values. All right, the second example is there's my scatter plot, and if I draw a line in the middle of all of those, the line is moving in the downward direction, and the dots are pretty close to it. The dots fit the line pretty good, and so we'd say those are correlated. There does seem to be a relationship between the points. As my x values get bigger, my function values look like they trend in the negative direction. The pattern is that they move in the negative direction. And we say that's a negative linear correlation. The last example, now I can draw a line between them, and if I did, it does look like as I move down, the dots are going up. So I'm going to draw a line sort of in the middle, try to get one in the middle of all of them. And so it does look like there's a positive correlation, but because the dots aren't, like the other one, they're really tightly packed into the line. They're far away in this case. And so in this case, they would have little to no linear correlation. They're not near my line, these dots are well off of, far, far away from my line. And so in that case, we would say they have little to no correlation. There's not a real good pattern there because they jump around way too much. Whereas these are sort of tightly packed in here, right? They're not very far away from my line. These jump well above, well below my line that I can draw. And so we'd say there's little to no correlation in that case. All right, so I'm going to do a couple of more examples of our scattered lines and what kind of correlation, and a couple of actual application types. So this is a graph that we got where it correlates the husband age, all right, so that would be on the x-axis, with the wife's age, that would be on the y-axis. And so is there a correlation as the husband ages? Is there a correlation in the wife's age? And so if I look at this, it does look like it's trending in the upward direction. As the husband gets older, so does the wife. Okay, that should make sense. So I could draw a line in the middle of all these dots. All right, and the line goes pretty solidly in the middle there, and I have about the same number above as the same number below, and so we would say this is a positive correlation. And I'd say it's pretty good. I'd say it's good. I wouldn't say it's very good, but I'd say it's a pretty good correlation. The dots are pretty good there. All right, second example. So years ago, I put into a program the correlation between attending, so missed classes, and exam scores. And again, there does seem to be a correlation between the more days you miss, the lower your exam score. So I could kind of draw a line in the middle of this information, and the line does move in the negative direction. And so we would say this looks like it has a negative correlation. And it should make sense. The more days you miss, the worse you typically do on exams. Although, again, this wouldn't be as good of a correlation as the last one because the dots are kind of around it, but there are some few that jump way out. And so we'd probably say this is a correlation, but it's probably what we'd say is a weak correlation. All right? It's not perfect, but it's, again, not strong either. I wouldn't say it's a strong correlation. It's somewhere in the middle. It's a middle correlation. It's on an average, the middle correlation value. All right, then the last example would be a scatter plot where the points are just everywhere. All right, so shoe size and income, right? That should make sense that income and shoe size have no correlation. Size of your foot has no correlation on how much money you make, right? And if I were to try to draw a line in this case, I have no idea where the middle of the point is. It could go up, it could go down. So in this case, there would be absolutely no correlation at all. Not even a weak correlation. None. There's absolutely zero correlation between shoe size, and that should make sense. There should be zero correlation between shoe size and income. So I can think of the name. All right, we'll stop there. I'm going to pick up the next set of notes, which is we're going to talk a little bit more about a specific correlation value that we used in statistics and how it relates to graphs.